Welcome to qnawire.
All right, hello there. Today we're going to be talking about problem 15, which presents us with this pulley contraption called Atwood's machine. On the left side, we have a pallet of bricks that is 15 kilograms. And on the right, we have a counterweight, which is 28 kilograms. This is a three-part problem. The first part is asking us to draw a free body diagram, one for the pallet of bricks and one for the counterweight. So I'm going to do that here. On the left side, we have the pallet of bricks, and on the right side, we have the counterweight. So the idea behind making free body diagrams is that we want to identify all of the forces involved. The forces here in this system are going to be the force of gravity acting on the pallet of bricks and the counterweight, and then also the force of tension, which is acting on both of the weights and has an equal magnitude for both. So on the left, I'm going to do the pallet of bricks as force of gravity, which is pointing down, of course. And I'm just going to label that as F sub B. And then it's going to experience an upward tension force, which I'll just call big T. And then for the counterweight, we also have the same upward tension force. So I'll draw that arrow as the same length, and I'll call it T again. And then we also have the force of gravity of the counterweight, which I will label as F sub C. And that's just equal to the mass times the acceleration due to gravity. So it's also helpful here to identify what directions the net forces are going to be pointing in. So we know that since the counterweight is more massive, it's going to go down, while the pallet of bricks is going to be accelerating upwards. So we can draw these. I'm just going to draw these vectors for each of the masses. So I'll say that this one is F net sub B, or sorry, F net comma C. And then the other one, the pallet of bricks, is going to have an upward net force. So I'll call that one F net sub B. All right. So the next part of this problem is asking us to figure out the acceleration that the pallet of bricks is experiencing upwards. So I will start that problem right here. So first we want to write out the net forces for each of the objects involved. So let's write out the net force for the pallet of bricks. So we'll do F sub net comma B, which is equal to the mass of the bricks times the acceleration that it experiences. And we know that this term is going to be positive because the pallet of bricks is going to be accelerating upwards. And then we know that the net force is just the sum of all the constituent forces. In this case, it's just gravity and tension. We know that tension is pointing upwards, so it's positive, and gravity is going downwards, so it's negative. So we can write this as T minus, and then M sub B times G. And notice here that I am labeling the mass of the bricks as N sub B. The reason that I'm doing that instead of putting in 15 kilograms is because it's easier to work with the variables in this case, and then just plug everything in once we've got an expression for the tension. We could do the same thing for the net force acting on the counterweight. So we can say this is F sub net comma C. And this is going to be going downwards. We know the net force is downward, so we can put a negative sign in front of the M sub C times A, or just the definition of the force. And again, this is just equal to the sum of the forces acting on the counterweight. So this is going to be T, which again is pointing upwards, minus M sub C times G. We can actually move this negative sign right here to the other side in order to just keep the definition of the force positive. So we can have M sub C times A is equal to, and then this will be N sub C times G minus T. Okay, so now remember that we want to figure out what the acceleration is. In both cases, the amount that the bricks is accelerating upwards is going to be the same that the counterweight is accelerating downwards. So that's going to make this a little bit easier. So what we're going to do here is we're going to solve for the tension in one of these expressions and then substitute that in to the other equation and then solve for A. So I'm going to solve the F sub net comma B, which is the bricks net force. I'm going to solve that for T. So in doing that, we're just going to add the M sub B times G, the force of gravity, over to the other side. So we're going to have M sub B times A plus M sub B times G is equal to tension. And then we're just going to substitute that into the net force for the counterweight. And so we will get M sub C times A is equal to M sub C times G minus M sub B times A minus m sub b times g. All right, now all we need to do is solve for the acceleration. So I'm going to move this term over to the left side, and then I'm going to pull out a common factor of g from the gravitational force terms. So we have m sub c times a plus m sub b times a on the left side, and then we have g times, and then the difference between the masses. And then all we have to do is just pull out a common factor of a on the left side and then divide over the sum of the masses. So we're going to have a is equal to g times m sub c minus m sub b over the sum of those masses. All right, and now that we've figured out an expression that defines our acceleration, all we have to do is just plug in numbers. So we have a is equal to 9.8 meters per second squared times 28 kilograms minus 15 kilograms over the sum of those same masses. So 28 kilograms plus 15 kilograms. And when we do that math, when we go ahead and we simplify everything, that gives us an acceleration of 2.962 meters per second squared. And that is the amount that the pallet of bricks is accelerating upwards. So I'll go ahead and box that answer. And then the last part that it wants us to find is just figuring out what the force of tension is and then comparing that to the two masses. So what we're going to do is we're just going to take this acceleration, the 2.962 meters per second squared, and plug that into either one of our expressions for tension. So I'm just going to go ahead and do that for the pallet of bricks. So we'll scroll back up and identify where we have the net force defined. All right, so we have that MBA is equal to the tension minus MB times G. All we have to do is just add the force of gravity over, and I'm going to pull out a common factor of the mass just to do two steps in one just to make it simpler. All right, and then all we have to do is just plug in our numbers again. So we have the mass of the bricks, which is just 15 kilograms, times 2.962 meters per second squared, plus 9.8 meters per second squared, which is the acceleration due to gravity. And then when we go ahead and simplify this out, we get that tension is equal to about 191.46 newtons. All right, now all we have to do is just compare that to the weights of both of the objects in our system. So we have that the force of gravity of the bricks is just going to be the mass of the bricks times force of gravity, which is just 15 kilograms times 9.8 meters per second squared. And then same thing for the counterweight. It's just going to be the mass of the counterweight times gravity, which is just 28 kilograms times 9.8 meters per second squared, of course. For the mass of bricks, we have 147 newtons. And for the the force of gravity of the counterweight is 274.4 newtons. So now all we have to do is just compare these to our force of tension. For the case of the pallet of bricks, we see that the force of gravity is less than the tension, which means that the tension is going to win out, and thus the pallet of bricks is going to accelerate upwards. And similarly, the force of gravity of the counterweight is greater than the tension, which means that gravity is going to win out and the counterweight is going to accelerate downwards, which solidifies our reasoning at the very beginning that the counterweight is going to accelerate downwards while the mass of bricks accelerates upwards. All right, so that is the problem. I will hope to see you next time and have a good rest of your day. Thank you.